once again to the Emoji Maths and Science. In today's class, we'll be working on how to differentiate using first principle. I'll use two examples to show you how to differentiate using first principle. And in subsequent classes, we'll see how to differentiate using the formula, which is very easy. It is easier and it is straightforward. But to help us appreciate and understand it, let's get started with differentiation with first principle. Let's take the first question. Our first question says that y is equals to x squared. If I'm differentiating from first principle using y is equals to x squared, the first step is to consider a change in y that will bring about a change in x. If there's a change in y plus change in y will necessitate x plus a change in what? In x. Because I have a square here, all squared. That's the first thing. Let's call this equation 1. If you have any gray area, if you are confused or you have questions, please do not hesitate to use the comment section. And if this is your first time meeting our channel, kindly do subscribe to our channel. That way you'll be sure to get notified anytime we create such lessons as this. Now, we have gotten our equation 1. Y is equals to x squared. And a change in y, we have seen that it will necessitate a change in x. So that we'll be expanding this. Y plus change in y will be equals to x plus a change in x into x plus a change in what? In x. So that y plus change in y will be equals to x times x, x squared. X times change in x change in x, plus change in x times x change in x, plus change in x, all squared. Now with this, my y plus my change in y is the same thing as x squared plus this becomes 2x change in x plus my change in x all squared. So that I can now call this my equation 2. Now we will subtract equation 1 from equation 2. If I'm subtracting equation 1 from equation 2, it becomes this y will subtract with y. I will be left with a change in what? Y equals x squared plus 2x with all of this expression minus what you have here. X squared will definitely give away with x squared. I'll be left with 2x plus my change in x plus my change in x all squared. So that at this point I'll be dividing both sides. You divide through by your change in x. If I divide both sides by change in x, my equation becomes change in y over a change in x to be equals to your 2x change in x plus your change in x all squared. Here is over change in x. Here is over a change in what? X. With that, this will cancel 1. I'll be left with 1 of the change in x. The change in x here will cancel the change in x here. So I'll be left with my change in y over a change in x to be equals to 2x plus my change in what? X. Differentiating from first principle at this stage tells us that as my change in x begins to tend towards 0, my change in y over change in x tends also to dy dx. So that at this point, this is definitely going to become 0. On 2x, there is no change in x. Delta change in y over change in x automatically becomes dy dx, which is equals to 2x. Now, this is differentiating from first principle. If you have any gray area, please do not hesitate to use the comment section. We'll be there to respond to you. Let's take a second question. second question says that, let's take this, y is equals to x cubed. If y is equals to x cubed, remember that the first thing we should do is a change in y that necessitates a change in what? In x. That is, y plus change in y will be equals to x plus a change in x all raised to power 3. Now, so that y plus your change in y will be equals to, when you expand this should be x plus change in x into x plus change in x into x plus change in what? X. So that if I'm expanding the first one, my y plus change in y is equals, let's expand this. This is actually same thing as x squared plus 2x change in x plus change in x all squared. Now you multiply that again with x plus your change in x. You remember we call this equation what? 1. We're getting to derive our second equation. So that my y plus change in y is the same thing as, by the time you expand this, x will multiply this, become x cubed plus 2x squared change in x plus x change in x all squared. This should multiply this again to become plus x squared change in x. This multiplies this plus 2x change in x all squared plus change in x raised to power what? 3. Now let's sum this up. On summing this up, we should have y plus change in y equals x cubed. I have 2x squared, x squared change in x. That becomes plus 3x squared change in x plus, I have change in x squared plus x. I have this plus this becomes another 3x change in x raised to power 2 plus change in x raised to power 3. Now, remember that we're going to divide. This is our equation 2. We're going to subtract. We're subtracting equation 1 from equation 2. So that this becomes change in y, because y plus delta y plus change in y minus y. I will be left with a change in what? In y. X cubed plus 3x squared change in x plus 3x change in x squared plus change in x all raised to power 3 minus x cubed. X cubed will give away, this and this will give away, and I'll be left with 3x squared I'll be left with 3x squared change in x plus 3x change in x all squared plus change in x all raised to power what? 3. Remember that now we're going to divide all through by our change in what? In x. So that this becomes your change in y over change in x to be equals to, if you divide this by change in x will cancel. I'll be left with 3x squared plus, if you divide this, I'll lose 1 of the change in x. We'll be left with 1 of the change in x. 3x change in x plus, if you divide this, you'll be left with 2. That's change in x all squared. Now, as change in x begin to tend to 0, the change in y over change in x tends to dy dx. So that at this point, my change in x is going to become what? 0. So that this becomes dy dx to be equals to 3x squared plus, this is going to become 0. Because I have a change in x here, which is multiplying by 3, it also becomes what? 0. So I'm left with 3 what? x squared. So the y dx is equal to 3 what? X squared. Thank you for staying with us. If you have questions, please do not hesitate to use our comment section. And like I did promise in our next lesson, we'll be using the formula to solve the same sets of questions. Thank you and do have a nice day.